So this is a continuation of section 2.4. We're going to look at example 4 here. Example 4 is function f of x equals 1 over x. And so we're going to find the slope at x equals a. So we're finding the slope of the curve at some arbitrary location a. So we start with the definition of the slope of a curve at a point, and that is the limit as h goes to 0 of the function at a plus h minus the function at a over h. So let's set up the expression for the function value at a plus h. So we know that the function is 1 over x. So the value then, if x is a plus h, is 1 over a plus h. And then the function value at a is 1 over a. So the tricky part here is getting through the math. And that means getting through simplifying the numerator here. The 1 over a plus h is going to be that function value here, and then minus 1 over a. So let's take a look at that, simplifying that algebraically. So we put those two expressions in the numerator, and we notice that the common denominator then is a times the quantity a plus h. So we're going to multiply top and bottom by that common denominator. And when we do that, we can get some canceling occurring. So for instance, in this first expression, the a plus h cancels. And in the second expression, the a's cancel. And so after that, then we have, in this first expression, we have a. And in the second expression, we have minus a plus h. So we have a minus the quantity a plus h all over a times h times the quantity a plus h, which is the denominator here. And so when we simplify this, we can simplify this by distributing the negative sign. And then we notice that we have a minus a, which is 0. So we're going to cancel out those a's. And so we can simplify this a little further to minus h over h times a times the quantity a plus h. And so if you notice here now, we can cancel the h's. And so we have, and then we're going to take the limit as h goes to 0. So that's why we can just say this is equal to 0 here, this h value. So we have negative 1 over a squared. So that is the expression for the slope of the line, or the slope of the curve at any arbitrary point a, or x equals a. So what does that mean? Well, here is 1 over x. So if we think about this expression for finding the slope, let's say, the nice thing is that we can find the slope anywhere now. So we can use it anywhere along the function. Let's take a look at a equals 1. So let's take a look at this point right here. So if a equals 1, then the slope of the curve is negative 1 over 1 squared, which is negative 1. So here's the value of the slope of the curve at 1, it's negative 1. In other words, we have a line that we could draw with slope of negative 1. It would be tangent to the curve at that point. We can pick another point. Let's pick like a equals 3. So if a equals 3, then the slope is negative 1 over 3 squared, which is negative 1/9. So if we look at this point at x equals 3 and we draw a tangent line, that tangent line has slope of negative 1/9. So where then, the next question is, where is the slope negative 1/4? So if we think about that, going back to the previous slide, we have a slope of negative 1 here on the red, negative 1/9 in the green. So negative 1/4 must be somewhere in between. So we can set those two expressions equal to each other, the negative 1/4 equal to the expression for the slope. And then we can go ahead and solve this algebraically. So notice when we cross multiply, we get a squared equals 4. And when we solve that, we get a is plus or minus 2. So let's talk about that a little bit. We know that we see the plus 2 value here, going back to the previous screen. So if we draw a tangent line there, we're going to get a slope of negative 1/4. So what about the minus 2 answer? So if we graph this in our graphing calculator, we graph 1 over x, put that into y1, and let's pick a nice window here of -6 to 6 on the x and -3 to 3 on the y, with scales equal to 1, so that's in our window function. So you might want to pause the video right here to get all that set up before, and then resume the video so to see that your graph matches the next screen. So you should be back now if you've paused. And so we're going to hit the graph button now after we've set up our window. And here is our window. So where's the slope equal to -1/4? Remember, we had that answer of plus or minus 2. So here is plus 2. We should have a slope of a curve of equal to -1/4. And here is minus 2. So again, we should have the slope of the curve equal to -1/4. So those two tangent lines have slope of -1/4. Here's another example. It says write the equation for the normal line to the curve. So in this example, one thing you have to acknowledge is you're asked to find the equation for a normal line. So not only do we have to find the slope, but then we have to write an equation after finding the slope. So we're going to start out with the definition of the slope. And so our definition of our slope is here, to the slope of the curve. And when we're talking about finding the slope at x equals 1, that means a equals 1. So that means this expression in the definition has to be equal to 1. So really what we're trying to set up is an expression for the function. So the function value at 1 plus h. So we have to be careful here because we have to substitute in 1 plus h in and square it, which means we have some FOILing to do. So be really careful about that. And then we can substitute in 1 for our a value, and that's just a straight function value like you're used to doing in algebra and algebra 2 and pre-calc. So when we substitute in the value of 1 here, we get 4 minus 1 squared, which is 3. So we're going to put those two expressions into our definition of the slope of it at a point, the slope to the value of the slope of the curve at a point. So here's our f of 1 plus h. Here's our f of 3 divided by h, or f of 1, excuse me, divided by h. Simplifying that, notice that we have 4 minus 1, which is 3. Minus 3 is 0, so we're just left with 2h plus h squared. And distributing the negative, so we have negative 2h minus h squared. So I'm going to factor out the h's so I can acknowledge that they cancel top and bottom. And so, and then we can take a limit right away because minus 2 minus h, we can plug in 0 here for h. And so we get a slope of -2. And so now that we know we have a slope of -2, then that's just a number. Remember, that's just the slope. We know that the slope of a perpendicular line or a normal line is the opposite reciprocal. So the opposite is a positive number. Reciprocal is 1/2. And we're talking about the point x equals 1. And remember, when we substitute 1 in, we get a y value of 3. In fact, we can see that right here on that function expression. So we've got a slope of 1/2, a point of 1, 3. And we love the slope point form because it involves absolutely no math. It's that easy. You just plop in the slope, plop in the x value and the y value, and you've got your equation for the normal line. So if you notice, the answer is in equation form because they're asking us for an equation for a line. So looking at this function, there's the curve 4 minus x squared. And here's the point, x equals 1. And here's the tangent line. That tangent line had a slope of -2. And then lastly, the question they're asking, here's that normal line. That normal line, if you notice, that slope is up 1, right 2. That's a slope of 1/2. And if you notice, we come back to an intercept of about 2.5. And if we would have solved that for slope-intercept form, that's what we would have gotten. The last example we're going to go through is an example with finding the speed of a falling student. Exactly 1 second. So, so if we think about free fall, and knowing what you know about free fall, the equation is negative 16t squared. That's 1/2 the acceleration due to gravity in metric units. And so if we also know that the speed is the rate of change of position, so speed by definition then is a slope. It's the average. It's the rate of change of the position over time. So we start with our definition for slope of a curve at a point, and the point we're looking at is an a value of 1. And so I'm just going to, since this is a pretty compact equation, I'm actually just going to put it right into this fraction expression. So if you notice, we have 16t squared, so negative 16, 1 plus h quantity squared, that's our negative 16t squared, minus negative 16, so when I plug in a t value of 1, I get negative 16 times 1 squared, which is negative 16 over h. And so now we're going to have to FOIL out this first expression in the numerator. So I've got negative 16, and then this FOILed is 1 plus 2h plus h squared plus 16. And so if I distribute the negative 16, I'll get negative 16, negative 32h, and negative 16h squared. So I get negative 16 and positive 16. Those are going to cancel. I'm going to be left with the negative 32h minus 16h squared. Remember how I'm telling you that these constant terms should always cancel. If they don't, recheck your math, because they should. And we'll get into why those constant terms always cancel when we talk about slope in chapter 3. So we can factor out an h from the numerator so that we can cancel it with the denominator. So we're going to go ahead and cancel those. And so now we know that we have this expression for the slope. It's negative 32 minus 16h. And as h goes to 0, this whole term will go to 0. And we see that the slope then at 1 second is negative 32. And so if slope represents the rate of change, then the rate of change of the student's position at exactly 1 second is negative 32, which means that the student is falling at negative 32 or 32 feet per second downward exactly 1 second into the fall. So velocity is a rate of change. So by definition, like I said, it was a slope value. And since we used the limit here, and we didn't do just a rise over run, but we actually took the limit of a function, that means we call it an instantaneous rate of change, meaning it's defined at 1 point, and that point is t equals 1 second, as opposed to using 2 points to define a rate of change. So just to kind of recap, we've hit 2 really big concepts here. We've hit average slope, which is the average rate of change. That's just your rise over run. That's just your straight slope as you know it since algebra. And then we have, and for average slope, we need 2 points to figure that out. And then we have a slope at a single point. And a single point is when we need our calculus. So that's taking our rate of change and taking the limit. Okay, those 2 concepts are really often mixed up by calculus students. So when you see the word average, think 2 points. When you see the word slope at a point or instantaneous slope, think I got to take the limit. Okay, so likewise, if we relate this to motion, like in physics, average velocity is just like average slope. It is rise over run, total distance traveled over total time. Instantaneous velocity, which is velocity at a single point in time, like velocity at exactly t equals 1 second, you're going to have to apply that definition of the slope at a point, which is taking the limit of that slope expression. So so these are often mixed up as well. Again, think average. You got to have 2 pieces of information. Instantaneous, we only need 1 piece of information. So, and again, that velocity equals the slope. So at this point, since we've gone through both of those examples, you should be ready to start on the homework for day 2.